So, hello, how is everybody? I can't hear you, so I assume everyone's doing great. My name is Mitch Whitson with a couple firms. The one that I'm really going to focus on today is a firm called California Filtration Specialists. Our expertise is the design and build side of stormwater treatment systems. And what I'll do is I'll give you guys a brief summary. We'll talk about the fundamentals of low impact development, green infrastructure, and then at the last moment, in the last half, what I'll do is I'll show you some of the solutions that we have. I think you guys will like them, certainly from a design perspective. They offer some things, they offer some qualities that you don't quite get with some of the old school concrete solutions that we find so much in this industry. And then I will hopefully have some time at the end to answer questions. If not, you guys can always pop me an email. But what I will say, one of the things that we like to do is we like to help. So even from a very conceptual basis, if you are in a design of a project and all you've done is your map and you're just looking to develop a project, you haven't even got into the civil side of it, throw it to us, because that's the best time to incorporate these concepts. If you go down the road of a design and you're mostly done with the civil side of it, we frequently have to go backwards and kind of start changing things. And it's just at that point, it really, the benefits of low infrastructure kind of go away, because you've built the infrastructure of the project to basically, handle the water old school. So I will be quick. I have a lot to go over. So let me introduce ourselves and start talking. So again, Mitch Whitson, California Filtration Specialists. We're vastly different than any other traditional manufacturer / distributor. And the reason that is we are founded as a heavy civil CM firm. I'm one of those Cal Poly kids that, run around doing construction, but my first job was over 30 years ago, was a highway widening. So we've been in these heavy civil space. We were founded as a heavy civil CM firm. Owners will hire us to do developments. We still do CM. We started getting into water in the early 2000s. And if people are from San Diego, you're probably familiar with 4S Ranch, Rancho Bernardo. My first contract as a company is we built about $75 million worth of offsite obligations. One of those projects was Carmel Valley Road on the left, and the developer on the other side of Lusardi Creek discharged some large desiltation basins directly into the creek. Downstream, there was a farmer that was under enforcement action by the state water board, and that development got shut down. I was a separate permittee in the same property, so I was allowed to proceed. But it was interesting because I'm on the side of a mountain. So I was dealing with water purely from a self-preservation perspective. But the state recognized that we're on my project weekly for better part of a year. And kind of saw that we were really paying attention to the water aspect of the large development, certainly in this type of project where it's a multi-year project, millions of yards of rock. So they asked us to start looking at the construction general permit. So we founded our stormwater compliance division before the new CGP came out. I think we started our stormwater compliance division in 2007. One of the first things we did as a compliance firm is we helped mitigate the violation, a cleanup and abatement order on the Sprinter rail. So again, anyone in San Diego, was a 22-mile track from Oceanside to Escondido, over 44 miles of right-of-way. They were out of violation. They were out of compliance for a total of 15 months. We came on because again, we take things from a very proactive perspective, because as a CM, we're trying to drive that project home, complete it in time, do it under budget. We were able to get 44 miles of right of way 100% compliant in less than 3 months. The State Water Board recognized the only reason they were compliant was because of us. So we stayed on board until the project was done and closed out. Construction water quality compliance led us to industrial water and led us to municipal water quality compliance. So what we do on that is, I think that industrial and construction, while there is compliance aspects, it really is rooted in treatment systems. It really is rooted in, if you're not doing something to reduce pollutants from a job site, you're really not doing anything. So we started California filtration specialists with the understanding that there were treatment systems. We needed to treat the stormwater. So on the Whitson side, we have a full slate of design build options. Anytime you have us look at a system, we will give you installed cost because we are an A licensed engineering general contractor. So enough about us. Let's talk low impact development. So conceptually, what we want to do from the very beginning is, if you look at the hierarchy of what the state's wanting you to do, and it's not necessarily even the state of California, it's kind of nationally, the first thing you want to do is you want to infiltrate. And the reason is you get the benefits of recharging your aquifers, but also that, soil is not dead. I mean, maybe in the deserts it is, but, soil has properties that treat those pollutants, the root structures of the plants, the anaerobic bacterial action of the soils themselves. Soils are very much alive, and they treat the pollutants as they flow through. Certainly there's some pollutants that, soils can't treat, organic soils can't treat, but, they do treat the water. So, I mean, that's exactly why you can pump from a well and you got potable water. So, you want to infiltrate, they're going to make you infiltrate. And in San Diego, the infiltration rate is extremely low. And if you hit a certain threshold, even though it's extremely low, you're going to have to infiltrate the 85th percentile that hits that property. Well, what happens if the soils don't flow? Well, in the past, we've tried to do dry wells. I'm not a big fan. They're expensive, they're costly to maintain. But more importantly, what they do is they're a direct path from the stormwater pollutants directly into the groundwater table. Yes, they do some type of cistern, but it really is a shortened path from the groundwater table. You're putting that directly into the ground, but it's just an expensive option. So I've never been a big fan. I will show you some opportunities that if you do not have infiltration, I'll show you some technologies in a moment that will work and actually change kind of the parameters of the soils. If you can't infiltrate, the states, all of the stormwater manuals want you to do bioretention. I'm not a fan. And the reason I'm not a fan of the concept of bioretention is because what it basically is doing is it's combining two concepts that are not necessarily dependent upon one another. There's the bio component, which I call the water quality component, but they tie it to a traditional media, which is a mixture of sand, compost, or topsoil, some combination, and then they restrict the flow rate through that media cell, traditionally 5 inches per hour. You do not have to have a big basin. You do not have to have this big treatment area. You do not have to flow at 5 inches per hour. Most importantly, there's no proof in the pudding. So, we had a project we're the construction manager of in wine country, and they had us put a traditional basin. You look at the county manual is a mixture of sand and compost. Well, what happens when compost breaks down? Well, it releases nitrates and nitrogens. Well, what was the pollutant concern in the real water body that we were discharging to? Nitrates and nitrogen. So I'm putting a system in the ground that's actually going to exacerbate the situation and make it worse. So, it just isn't, bioretention conceptually back in the day, it made sense, but land is expensive. Is it a cheap way to go? Absolutely. But do you have acres of land to give? And in most instances, you don't have acres of land to give. So can we do it smaller? Absolutely. We have a high flow there are high flow biofiltration systems on the market. We control a product called Focal Point, flows at 100 inches per hour versus the 5 inches an hour. So I'm about 20 times smaller footprint. So instead of you having that 1,000 square foot, you put a little 20 square foot. We can also reduce the size of the focal point slightly by changing the ponding area, and I'll show you an example of that in a minute. But, focal point is a fantastic product. It's essentially Filterra without a box. The gentleman that invented the media for Filterra, it also invented the focal point media. The only difference is we do not put ours in a box. Where I've seen Filterra systems, I'm not here to bash on Filterra. It's a good technology. The problem is it just gets root bound. The plants die, the vegetation dies. Where focal point will perform and improve over time. You just don't see that in concrete systems because you're really relying on the media. You're really relying on the media versus relying on, again, soils, the anaerobic activity, the root structure that starts to coexist with its surrounding areas, and it really does a fantastic job over time. It also gives you flexibility of where you put it. So you can put it in planter boxes, you can put it in medians, you can put it pretty much anywhere you want. We also do a bunch of biocarbons. We do biocarbons. We've got 2 primary biocarbons we deal with. I'm a big fan of biocarbon. It's you see biocarbons and GAC, granulated activated carbons. They surround us every day. Your Brita water filters, the water filters in your refrigerator. There's carbon even in the upholstery of your car to help sequester the smells, basically sweaty people sitting in a car all day long. It helps to that end. But what it does is, basically it's an organic material that is cooked under a process called pyrolysis, an oxygenless heat. And what it does is it basically pops all the individual cells. So a cubic yard of biocarbon actually has close to 35 to 36 square miles of surface area. So it really does a fantastic job of sequestering pretty much any pollutant that flows through the media. So we have 2 different medias, slightly different in the way they actually treat, but we've had great success doing biocarbons on industrial sites and getting them back to baseline. If you can't infiltrate, if you can't do a biotreatment, a biofiltration system, then you're permitted to do a filtration system. So because of the change of technology, I think it's very difficult to go to the filtration component. And the reason that is there are solutions, there are answers in the biofiltration side of the equation that there weren't years ago. However, filtration is very important because while you're not doing a new development where you're forced to go into a tape protocol, for example, or do a biotreatment or kind of go through that checklist of, can you infiltrate? No. Can you do this? No. And then you finally get the filtration. There are instances where filtration is very important. Industrial facilities is a good example. Non-industrial facilities that don't fall into the confines of a new development where you are actually, but you're being pushed by a municipality to treat pollutants from leaving your site. Then filtration really comes into play. But it's a very interesting conversation because it's a pollutant-specific, site-specific model. And the mechanisms for treating the pollutants change by technology. So we do have a lot of filtration options. In fact, we have the only antibacterial, antimicrobial filter license in the state of California by the Department of Pesticide Regulations. So I'll get into that in a moment. So sticking with the concepts of low impact development, green infrastructure. Traditionally, what people like to do is, what do we do as an industry? What do we do as civil engineers? Well, we capture the water in a catch basin. We put it in a 10-inch pipe that gets this 10-inch pipe, turns into a 15, turns into an 18, and we basically capture the water, put it in a concrete pipe system or a ADS pipe system, and then we discharge it off of a project at a single spot. Once all of a sudden runoff coefficient and runoff equalization came into play, and that really took, 2009 is when everything started to have to equalize. You didn't have to try. Back in the day, you just had to try to equal those values. Now in California, they have to equal. So what do? We started building we either started taking lots to put basins in there, or we started going with something we're familiar with, septic systems, very wide, flat systems, a lot of surface area. Your storage volume is mostly found in your rock, but it's a very flat, wide system. Yeah, it works. But when rock gets costly, then the cost of the system goes up greatly. Fortunately, in many municipalities in California, rock is fairly inexpensive, so it's a good way to go. But again, you're taking land, you're taking opportunities, and you're costing more money for those pavement sections just to go to a traditional model. We can do that with our modular tank system. Instead of being 65% efficient, we're 95% efficient. So you're reducing that footprint, reducing that area that you're taking land. But the question is why? Why are we doing that to begin with? Why are we taking lots? Why are we taking lands? Because you can treat, technology's advanced so much now that you can treat with green infrastructure and low impact development technologies on a lot by lot, DMA by DMA basis. This is very frequent for us. We're doing a job in Laguna Niguel. Started off as 4 primary DMA areas. I think by the time we were done with it, I believe there's 14. And we're treating in a variety of fashions at each DMA, depending on what is the most efficient and cost-effective system. So you don't have to do a complicated storm drainage system, put it out to a big tank system. You don't have to do that. Certainly in the desert regions, we're doing some things out in Palm Desert and Indio, where we're completely eliminating the storm drain system off of properties. Just because the infiltration rate was so high, why are we capturing stuff in catch basins, piping it to a cistern? Why not use an efficient permeable paving system? And we'll talk about those in a moment. So green infrastructure, low impact development, follow that hierarchy, follow what we're trying to do with stormwater, and really think decentralized, really think about tearing that you don't have to go down a traditional model. So I'm going to touch on infiltration real quick. Obviously I'm not a fan of dry wells. So let's look at a technology very quickly, because this is something that is going to take a while for us to talk about. But we do control a project called Parjana. Parjana is very interesting. It's not a direct path from the top down into the groundwater table. In fact, what it does, it caps each of these individuals. So think about a square tube in a round hole. You drill an 1 3/4 hole, you put an 1.5 inch system in it, you start to get some microfracturing around that system. And in essence, what happens is this area starts to saturate next to this area that begins to saturate next to this area. So basically what you create is you create a saturation zone in an impermeable soil. And once it's saturated, actually water starts to flow. It's a pretty interesting concept, but we'd have to take some time and get into it with some details. So if you're interested, please reach out. We'll get everyone on board and we'll give you a presentation specific to this. But so this is a typical layout. This is a project that we built in, Central Valley of California. And what they had is they had a large basin, basically a desiltation dewatering basin. And it wasn't flowing. It was they built it right on top of a hard pan clay. And the farmer was having issues with all his surrounding almond orchard. So all the plants that were anywhere close to this basin were basically drowning, and they weren't getting any production out of it. And so what they did is they basically surrounded that basin with a well point. Inside the basin itself, they did another Parjana system. Well, now all of a sudden that's no longer saturated, and those trees are all back to life and producing for this farmer. Here's an example of a project that was done in Fresno with the city of Fresno. This shows you the power of Parjana. Prior, it was meant to be a recharge basin, a groundwater infiltration recharge basin. In 2,500 days, they infiltrated a total of 30 acre feet. They were losing 70% of their water to evaporation. It wasn't recharging the aquifer that they was hoping it was doing. Once they put Parjana in in less than a tenth the time, they doubled 2.5 times the infiltration rate. So now instead of losing 70% of that water to evaporation, over 90% of that water is actually going back into the ground, and that's the intent of it. But this is a really neat case study, and we've got several case studies that will show what you're doing with Parjana. We're building a few throughout California now. They do it on sides of roadways where you get that hard pan clay, and now you have a vehicle liability issue because around a corner you end up with a big pond of water for a month. We've got some larger distribution facilities where we're able to greatly reduce the size of a basin just because you don't have that 5 or 10 acres to give to build a big giant basin. So Parjana can be put into existing basins on the sides of roadways. It really is a neat technology, and if you guys are interested, please reach out. We'll talk about it. So going back to infiltration, if you can infiltrate. If you can't, there are technologies that are going to help you reduce the size of your basin and expedite that flow. Just an interesting way to approach. So what I want to talk about now is permeable paving systems. And, one of the biggest problems we have with permeable paving systems is that in California, we don't get, we're not back east, we're not in the southeast, we're not, we don't get rain 12 months a year. We get that 0.03 of an inch in September. We get 0 in October. We get some in November, and then December, all of a sudden you get, oh, there's 1/100 of an inch. Yeah, there's 1.5 inches there, but you can see just by the way our water comes, we barely drizzle, we barely drizzle, we barely drizzle. So we get, 7 or 8 months of extremely dry, dusty weather. And then all of a sudden you start getting some drizzles. What happens in a small pore space? What happens when you have a very small permeable paving system traditional model? Well, the Brookings Institute basically shows what happens. Infiltration rates of porous asphalt concrete will initially exceed 2,000 inches an hour, while the long-term rates will actually go down as low as 2 inches per hour. That also holds true for traditional paver systems. What you do is you basically build a kind of, I'm not going to use the word complicated, but you use a complicated substructure. You bind it by a curb system. You use these small blocks, 3 to 4 pound blocks, and you rake sand in them. You put aggregate in them. You put pea gravel in them. You put something there, but you're basically taking that void space in between the blocks. Same as the permeable pavements, you have a very small pore space, and you get that dust, a little bit of rain, dust, a little bit of rain. Well, all that dust turns into mud, and it starts to solidify, and the system fails over time. The other problem with a traditional paving system is the cost of the system itself. Traditional asphalt, $4 or $5 a square foot. Concrete is $7 or $8 a square foot. You're usually looking about a $12 to $15 per square foot system that's ultimately going to fail. Yes, it looks good, but it's going to fail. It's just not going to work over time. So let's look at permeable paving systems from take a step back. If you look at it just on the outside and you're saying, hey, I'm going to build this parking lot, and I'm going to pave all these parking stalls, and I'm going to do a traditional model because now we have water quality components. Well, here's a traditional design using our focal point. We've got to treat this property as fast as it goes. Clearly there's not a lot of room here. So we had to go with a high flow biofiltration system, and you use 250 square feet of a high flow biofiltration that goes to a tank that leaves this property. This one was interesting from a couple perspectives. A, we figured out it was pretty costly, but B, we had a very low invert elevation to tie into. We only had about 3 feet total. So we're trying to squeeze a system into a very small vertical space. But in this instance, let's just talk about traditional design. You're spend about $95,000 to go down this road to treat. But what happens if you actually use an efficient permeable paving system? Let's say you use one that actually works, and you flip this model. So instead of doing the filtration above the tank, you're having to treat it as quickly as it hits you. You're now having the opportunity to pond above the basin, above the treatment system. So now you have your storage area in front of you that allows you to sequester that water, slow it down, and look what it did with the biofiltration system. I was able to go from 250 square feet down to 35 square feet. And what happened in the process? We cut about 50% off the budget on that project. And we see this a lot. We're doing that. We've got a project in Southern California. We're working with a school district where, they were $270,000 of concrete tanks sitting behind about $100,000 worth of treatment systems, vault-based treatment systems, and an entire storm drain infrastructure. Well, let's take that playground, put in a permeable pavement system, and we were able to basically get rid of the entire storm drain system, the treatment system, and that concrete tank system. And at the back end of at the discharge location at the end of the property, we're able to have a very small bioswale. We essentially eliminated 100% of the cost of the storm drain system on that property. So instead of a $300,000 or $400,000 liability to treat stormwater, we're able to replace traditional concrete and asphalt playgrounds with a permeable paving system and eliminate all of those tanks, all of that infrastructure. So having an efficient permeable paving system will absolutely save you money and save you a lot of headaches. Yes, there is a break-even point, and we do models on all our project where we're looking at the balance between filtration, storm drain reduction, and permeable paving, but we'll do those models for you. So we got a couple primary, well, we actually have 3 primary 100% permeable paving systems. One is called Pave Drain. It's basically an articulated concrete block. Unlike those 3 to 4 pound small blocks that you're having to wrap in a curb and then fill those joints with sand to hold it all together, Pave Drain doesn't require that. Pave Drain, you basically have a 1/4 inch spacer. You always end up with a 1/4 inch gap. The flow rate through the system exceeds 1,500 inches an hour. We built a large parking lot up in Pinecrest, up the Sonora Pass, if anyone's by the Sonora area. We put that system in the ground 5 years ago. They have not had to vacuum out that system. In the Sierras, with all the pine needles and all that activity going on, the freeze thaw, the system's still supporting very well. It's still flowing very well. So I like the system. It's very durable. It flows at a fantastic rate. I'll give you some examples. Well, here's a good example. Unlike traditional paving systems, we don't necessarily, I'm not building a concrete curb around it. Talk to anybody who has a traditional paving system and say, hey, I'm going to put a paving machine right next to your block, and I'm going to put a breakdown roller, and I'm going to basically be right next to your system. They're going to lose their minds. They're not going to let you do that. But with Pave Drain, we can do that. We basically use the asphalt to kind of lock the whole system together. So we put the system down, then you pave right against it. It gives you a variety of shapes, sizes, and colors. We'll make it local to wherever you are at a local dry pack manufacturing facility. So you get the color palette of any CMU product. It also gives you, so you have a good, strong architectural application. The shape of the block doesn't change. That's one of the problems. But Pave Drain is a great system. We also have another system called Power Block. Looks very similar to this. Functions the same way. It's just a little bit thinner solid block versus an arch block with Pave Drain. So we do trench drains with them. We do sides of roadways with them. Here's a project we did in San Diego, and it was a historic facility. They wanted to go with a traditional trench drain system across this parking lot. We're going to spend $28,000 for this trench drain across this parking lot. It cost us $8,000 to put a Pave Drain system in. All we did is we dug the hole, we put a perforated pipe at the bottom of it, we wrapped it, filled it full of 3/4 crush, we put Pave Drain on top and paved right over it. So this for $28,000 or a Pave Drain system for $8,000. So again, when you go down this road of green infrastructure, low impact development, you're always going to have a cost savings associated with your developments. So doing quite a bit of this. We got some projects in LA coming up. One specifically is South El Monte. They were going to go with a road equalization project. beautification project, bike lane, sidewalk. But the problem was now they had to put in some water quality treatment. On this mile of road, they have over 35,000 square feet of traditional bioretention basin. How's that for a beautification project? You have a swale filled with junk. It just wasn't a good way to go. Where we ended up incorporating a paved drain system along the side of the roadway. Below the paved drain is our tank system, which I'll talk about in a moment. And then at the very end of this row, so basically sheet flow off the roadway, street flow off the parking lot, it fills up the R tank. If that overflows, it basically goes into the gutter. But we're able to now, instead of 30,000 square feet of bioretention basins, I believe we have less than 1,000 feet of focal point on these little median islands right before they discharge and tie into the storm drain system. So again, a great example of where incorporation of a permeable paving system completely changes the dynamics of a traditional model. So they did some tests in Florida, really wanted to see how well it does flow, filled it full of muddy dirt, made it muddy, drove over the top of it, let it dry. Then they did just a vac truck with a vacuum head off the top of it. We're able to bring it back to 90% of its original infiltration rate. Again, it's just a good, efficient way to go. If you just have a street vac system, not one of those little Toyota trucks that drive around parking lots throwing dust in the air, but a solid Elgin Whirlwind vac system. Just driving a vac truck over the top of this will suck most of the debris out of the system without ever even having to clean it. Again, Pinecrest Lake is a great example. 5 years, have had very little, but they do vacuum that street. They do have a street sweeper up there, and that's what's kept it clean this whole time. If you are looking for credits, there are grant funds throughout the state to put water back into the ground. We can incorporate infiltrator systems into the system that actually will directly monitor how much water you're putting back into the system, into the groundwater table, so you can qualify for grant fundings. We have a great strategic partner we deal with called Corvius. They help secure grant funds for this. If you guys are interested in talking about the new phase 2 permit in California, the new phase 2 permit in California is going to capture K through 14 schools, basically K through 12 plus junior colleges, community colleges. They're now going to have their own small phase 2. So we've teamed with a couple engineering firms, and we've teamed with Corvius, and what we're doing is we're going to a variety of school districts and similar watersheds, and we're working with them to basically secure those grant funds as a group. So Corvius is really good company. Again, if you guys are looking for ways to help fund these solutions, talk to us. We'll certainly bring them on board and help you find what types of money are out there. So great strategic partner there that we can help you in a variety of ways. Okay, here's another permeable paving system we deal with. This is really neat. What it is a system called EcoRaster. It's a permeable grid product used by the U.S. military, FEMA, NATO. They use it at all their operating bases throughout the world. We give you a 20-year warranty. But what's neat about it is it's a low-density polyethylene made out of 100% recycled plastic bags. So if we're talking about low-impact development, you should really bring the concepts of sustainability in there. We're all looking for solutions for recycled rubber tires, plastic bags. Well, here's a system that uses plastic shopping bags and turns it into a permeable grid system. But what's interesting about this, it's not like your traditional models. They're very weak. They're made out of polypropylene. They're made out of an HDPE. So they're going to break. They're going to fail over time. Where EcoRaster is made out of a low density polyethylene, it flexes, it moves. Interestingly enough, it actually provides tensile strength. We had a grant through Cal Recycle that helped us basically analyze the EcoRaster system with a rubber tire aggregate fill. And what we're finding is that, well, we're defining ASTM lateral tensile strength. So unlike your traditional paving system that's going to break or crack over time if you get a base failure, the EcoRaster system actually provides tensile strength equivalent to a Tensar geogrid system. So it comes, it's really fantastic. And the reason that, it's strong, it's durable, we're going to give you a minimum 20-year warranty, but it's very flexible and it's affordable. It's roughly cost equivalent to an traditional asphalt pavement. So now you don't have to make that financial sacrifice of, do I pave, do I do concrete, or do I use a permeable paving system? And you don't have to make that decision from a financial perspective because this system is very similar. So what do? You can put it directly on the grade. In fact, fracking companies, oil companies just go out there, they grade some land, they put this down, they start driving trucks on it. Pretty simple. Traditionally, we'll go ahead and dig a structural section, put down a geotextile, put in a crushed aggregate base. We don't use a traditional class 2 aggregate. We actually use a crushed rock base. So the water flows directly through the system, and we use the rock bed as our storm drain system. Parking lots, grass pave, it's got a great industrial use. I'll show you some residential uses in a minute. But it's actually has 2.5 times the load capacity of a traditional paving section. So I believe it's 72,000 pounds per square foot is what you need for a fire truck. We're at about 172,000 pounds per square foot with a EcoRaster system. So lay it down, start driving on it. 100% permeable. We also do slope failures, bank stabilizations, as far as permanent bank stabilizations. When you get into these large erosion control projects, you're looking for, a bonded fiber matrix is only lasts you 1 to 2 years. A rolled erosion control fabric is only going to last as long as those plants take life. But let's say you're in a situation like we are in California, where you don't get a lot of vegetative growth. EcoRaster is a great way to just wrap it over the slope, pin it down, and now you have a permanent structure to basically hold that, stabilize that slope. Here's the EcoRaster blocks application. It's a way in which you basically, instead of going with a tight grid system like that, you end up going with a system that receives 4 concrete blocks. It basically gives you a better look. It gives you a more ADA compliant feel. I was looking at this one on the left because what they use is they end up using recycled rubber tires in some of the applications. Well, all of a sudden I'm like, hey, if we have 100% recycled plastic bag grid, why don't we put 100% recycled tire in it? So we have now developed, through a collaboration with Cal Recycle, a way in which we could use rubber aggregate fill into this versus a concrete block. Here is an example of the rubber fill. Sorry for the poor video quality, but the water flows through this just extremely well. Again, you get the strength, and now you're built out of 100% recycled plastic rubber tire and plastic bag. So what do we do with it? Well, if you want it to look black like a traditional paving model, we fill it full of a black recycled rubber. If you want to put parking stalls, we put a blue rubber in it. If you want it to be UV charging stations, we put a green aggregate in it. Or if you want it to be trails, we put a brown. 100% recycled tires bound with the resin. So now you don't get the migration of any aggregate out of the substructure either. So, just the same technology they use in playgrounds across the state, you now can put rubber fill inside of your grid system that now will give you a permanent solid look with a variety of colors. Moving on, I know that we have tons, I'm running out of time, so let's talk tank systems. If you can't, again, coming from the top, infiltrate, get that water off the surface, you don't have to use a traditional storm drain system by the use of permeable pavers. Or if you can't, you need a tank system. Our tank is a solid way to proceed. Again, 95% void space. But what's interesting about one of the benefits of using an R tank system is it's actually third-party tested for both strength and long-term creep. So we have our ASTM and our AASHTO certifications. So what do? We can go deeper than other tanks, and we can go more shallow than other tank systems. So we start on our traditional HD model. We start with 7 foot of earth and color cover. We can go about 8 foot tall, so we're down about 15 feet. Let's say you need to go deeper. You can go with the SD modules. You can start at 10 feet of earth and cover, and you can be as shallow as 18 inches. Just a great modular system. We've built some very large systems in the state of California. We've universally been accepted and installed through the state of California. But what's neat about it? Well, it could be anything. It could be your infiltration system. It could be your rain harvest system. It could be your detention system. We could build in our inspection ports. We can create a weir system simply by just drilling holes in our outflow pipe size that's bed and buried inside of this tank. The only difference is what we wrap it in. You know, we wrap it in a 30 mil visqueen, or we wrap it in a microgrid, or we wrap it in a non-woven filament. The wrap defines what it is. If anyone tells you have to go concrete, yes, there are instances in which you have to go concrete, but a tank is a tank is a tank. Does it support the loads above it? Does it work for the application? How do you install it? How do you maintain it? All of our systems have maintenance ports. I did have one municipality asking how we can crawl inside this tank to inspect. You don't have to crawl inside of a tank to inspect. We have inspection maintenance ports that easily define whether there's sediment in there, whether the system's working. Every system we build, we will meet with the contractor. We'll either do it ourselves, or we will basically be out there to ensure it's constructed properly so that we will give you that warranty. We have maintenance rows that we do with these systems, all these black dots. You can flush water in this, the water will flow through, or if you have a long linear system, we do have maintenance ports. So now you can just run the jet through the one row of the system to isolate any pollutants of concern. So what do? Here's a traditional arch system that I was showing you earlier. Look at the storm drain design. Also look at the cost of what is the cost to build these parking lots. You know, you have to change how you build this parking lot above this. You can't have certain loading above this parking lot. You know, what about the cost of this Jiffy Lube? You know, you can't build this tank system before the Jiffy Lube because you can't put concrete trucks and delivery trucks and everything on there. So you're basically having to kind of build backwards. And that's something to think about. Or why not just isolate and put your tank where it makes sense? Put it in an area that's going to minimize your footprint. You don't have to be wide, flat, and shallow. You can be anything you want it to be. Utility conflicts. Let's say we have some utility conflicts. You know, okay, well, build your tank around the utility conflict. In fact, the bottom left picture is a system that was being built, and that water line was supposed to be below the tank system. Now it is. You know, under most conditions, what's going to happen when this occurs? You're going to stop. You're going to have to redesign the system. You're going to have to pay the contractor to sit around and wait for answers. You're going to be paying general conditions. You're going to have to redesign. Well, with an R tank, you simply split the tank, wrap each half, isolate the conflict, and move on. We've had several systems where we've ended up having this conflict, and the downtime for the contractor was literally an hour to 2 hours until they got a hold of us and we split the system, built off the end. So you can put it in cisterns. There's a system we put in San Luis Obispo, doing a traditional model over on this left-hand side. Then they're looking at this and they're going, well, we have to redesign the foundation of this building to make this system work. No, you don't. Build your tank around the foundations and the stem walls. Interestingly enough, this is not the final design because they ended up running into a big giant rock on the left-hand side of the system. So we took some of these tanks and we actually extended out this right side and made kind of a hammerhead off the back of it. So it gives you the flexibility to kind of move things around. We'll give you the tank volume, we'll give you the storage volume, and it can look like whatever you want it to look like. And we can now avoid those foundations and loading. System we did in Orange, California, you know, traditional design, $1.3 million, and they were going to lose this entire back half of this parking lot. Or we came in, we took the slab off of this building, we filled it full of our tank. We were done in 2 months at less than half the cost. So simpler is usually better. There's a system in which they increase the fill. The modules, the HC modules wouldn't work. So again, we didn't have to go back and redesign. It was really simple. We just added a Super Duty module over the deepened section and increased the height of the top of tank very simply, very inexpensively to solve that problem. This is the space we like to live in. You know, build a tank on a curb, wrap it in geotextiles, put pave drain on top of it, pave right next to it, eliminate that storm drain system. Your storm drain system is this paver system and the substructure below it. We have trash systems. This is kind of how we got into that market. We're looking at we're working for the city of Thousand Oaks. They wanted to understand how to go zero trash. We went and saw what everyone was doing in LA. They were doing automatic retractable screens and CPS units. They were spending 3 times the amount of money by implementing some of these other more, impactful products. The city has had no increases in their maintenance costs. We just simply got rid of that automatic retractable screen and we put in a middle screen right there. Just street sweepers handle all the large debris, but they've had no increase of cost. Also, ACF will give you a 10-year warranty on this trash guard system. So it's a polypropylene, but you don't get the UV degradation you do as traditional systems. So let's talk focal point here real quick. High flow media, 3 inches hardwood mulch, over 18 inches of a certified media system. It meets all the confines of a tape Gould system. We do not, unfortunately, have tape DOE Washington, but the studies done on focal point, including a study in the city of San Diego, well, it's on a Navy facility in San Diego, prove that this system meets and exceeds the DOE tape standard. So we have multiple studies that are tape quality. We just don't have the tape DOE Washington, but most municipalities accept it. We're doing it pretty much throughout Southern California. There are some municipalities that just won't look at it, but focal point's a solid system. We are able to give you back land. The tank system is not dependent on the media system. So we can basically take a very small footprint of focal point. We can build an expanded R tank underneath it. Here's a good example of a job we did in Chula Vista. The tank is not dependent on the media. So the media is right here in this existing island. We built a little leg of our tank into the tank system, and then we built a large tank system that met the hydro modification components. Oh, and we had another utility conflict. We simply split the tank and made it a little bit different. So there's a job that Kinley Horn did. Each of these small little green dots is a focal point. And we eliminated a massive traditional concrete vault system in the middle of the property. So pull this apart. I'm sorry, I'm gonna keep looking at my clock. I just want to make sure I get through this. So focal point, solid system, gives you all of the water quality results you need in a fraction of the footprint of a traditional basin. We separate the systems so that we treat the volume required, but we can also store and hydromodify in a tank. So we're giving you exactly what a bioretention system will give you. We're just giving you the land back and thinking a little bit outside the box by pulling this system apart. Think about if you end up building a small focal point system with an expanded R tank and another expanded R tank. What are going to be the repercussions of the design of the storm drain system downstream? They're going to get smaller. They're going to reduce the cost of the storm drain system. So not only are you making money and saving money on your treatment systems, you're reducing the overall cost of your storm drain infrastructure. Simple little curb cut. You don't have to build a $3,000 catch basin there. Don't have to build a $3,000, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14 systems times $3,000. You're $42,000 of savings just in catch basins. So think outside the box when you're going down this road. We do quite a bit of green infrastructure and public roadways. Simply get the water off, run into a storm garden of one of our pretext box systems. It goes into a focal point biofiltration system with an expanded R tank underneath. And in many instances, we could surround this system with a parjana. So you're getting the water quality, the runoff reduction, the flood mitigation, and now you're infiltrating on a small footprint in the public right of way. So you can integrate all these technologies with each other. You don't have to do these independent of one another. Very quickly, Fabco. Fabco is a fantastic solution when it comes down to treatment systems. And the reason is it's a very durable, long-lasting system. So you simply take an existing catch basin, you put in one of the Fabco systems. You could see that, it's kind of hard to see on this left-hand side, but this bridge system here allows you to reduce and expand the supporting shelf. So you can see how it hangs along the edge of the catch basin. We can do really any shape, size, or color. But what's neat about Fabco is the fact that it is licensed by the EPA, well, certified by the EPA and the state of California for antimicrobial action. So we are the one system that is licensed to treat bacteria. So, and the reason that is because it's a kill technology. As the water flows through this foam core is treated with a component that basically creates, I just call it a mini cactus field inside of this foam core, and it kills the bacteria through it. We can also put additional media in the bottom of the cartridge so that we can treat additional metals. Are we dealing with phosphorus? Are we dealing with metals? Are we dealing with, we can even put some carbon in there to deal with some of these other stuff. So neat technology, easy to do, easy to maintain. All we simply have to do is replace these cartridges each year. So we've done quite a bit of these on industrial facilities to bring them back into compliance. If you really want to maximize the bacteria kill, we can do a helix system. A helix system is a way in which we basically put the Fabco foam into an existing storm drain arch. We put it inside of a catch basin and we feed this down the outflow pipe. So now you've got 8 to 12 feet of actual bacteria treatment. So as that water flows through this media cell, it's not even media, but flows through the foam, it kills the bacteria. So we're getting up 99% bacteria reduction. We have quite a few trash reduction options in catch basin technologies. Again, Fabco's fantastic. We have some very high flow, very high-end metal reduction systems. This is a collaboration with the US Navy. They basically paired a focal point system with technology that they developed over 10 years to figure out what the most efficient way to reduce metals off of Navy facilities. We're at 98, 97% metal reduction, both suspended and dissolved through our system. So if you have metals, here's a way in which you can do it with 4 foot top to bottom. We control those patents with the US Navy. It's a great technology. I'll end it with this. I always like to just do this because, again, shows you kind of our flexibility. This is one system for us. It integrated tanks, pave drain, focal point. This is one system. People aren't typically looking at a system like this. They're not looking at but this is the way we look at this world. Why are we building a single tank? Why not build a multiple of tanks, interconnect all these tanks, get all those permeable pavers on those driveways? It's just an easy, good way to perform and treat a system. It's not one system, it's several systems, all integrated to get one solid treatment system. I apologize, it's just an awful lot to squeeze in an hour. But does anyone have any questions? Would you like to ask, or would you like me to go one by one through the questions, which I could do right now? Having trouble joining. There's some issues with, I'm sorry. So feel free, my questions, recording the Zoom if you're having joining. So it looks like all the questions here were mostly issues with getting in on Zoom.
There's one question at the end, Mitch, from Kristen.
Do any of these parts of the system need to be separated away from trees to avoid potential damage? Yes. Well, I wouldn't say that you have to, but what we will do, and we've put tree wells in between the tanks. So you simply split the tanks on either side, and then we could do a root protection system that forces the roots down below the tank. So it's a pretty simple solution to, we do generally create tree wells in between the tanks. We just build the tanks on either side. I can show you some very specific examples if you'd like to send me an email at either mitch@whitsoncm.com or mitch@cafiltrationspecialist.com. I will give you multiple examples in which we built these and have integrated trees into our design. So I hope this was beneficial. Please reach out. Like I said, give us some conceptual designs. Even if it's very conceptual, we'll look at the regional standard. We'll figure out what flows we need to treat. We'll give you some designs that will give you some food for thought. Like I said, that job we're doing in Laguna Niguel started off as a 4 DMA system, ended up being a 14 DMA system. We incorporated permeable paving tank systems and focal points throughout the project to treat in the most efficient fashion. We're building a project with Toll Brothers in Lake Forest, 2.5 acre traditional basin. That 2.5 acre basin is now a 5,000 square foot focal point system. And that basin is now a soccer field, dog park, and playground for use of the community. We're in the business of giving you lots back. We're in the business of giving you land back. So if you're being constrained, call us, because I think we've got great solutions for you.
Awesome. Well, we are about out of time. Big thank you to Mitch. This was an awesome presentation. And if you missed any part of it, or know someone who would like to watch it, or you want to rewatch it, it will be available on our website later today or early tomorrow. And as far as other workshops this week, we've got a whole bunch lined up for Stormwater Awareness Week. We have one about active treatment system starting at 9:15. And at 10:30, you're not going to want to miss the workshop. We are live streaming from Yosemite National Park about the meadow restoration of Ahwahnee Meadow. So again, that's at 10:30. You can find all of those on our website. But thank you so much for joining us today.
Fantastic. Thank you very much, everyone. I hope you have a nice day.